Now again consider another result. Again it is very interesting. If c greater than 0, limit c power 1 by n equals 1. Limit of the sequence c power 1 by n equals 1. C greater than 0. So, when c equals 1, c equals 1. When c equals 1, it's an unhappy result. Why? Because that is immediate. When c equals 1, c equals 1, so what is the sequence? C power 1 by n. Secant c power 1 by n means it is 1, 1, 1, etc. Okay. Means the range of that sequence is nothing but a singleton set 1. Means it's a constant sequence. Therefore, the limit of that sequence is 1. Means that constant. Therefore, when c equals 1, so the limit is immediate. So the result is immediate. That is limit c power 1 by n equals 1. When c equals 1, that is immediate. Okay. Second case, if first case, if c greater than, suppose c greater than, when c greater than 1, you can choose c greater than 1, you can choose c to the power 1 by n equals some 1 plus dn, d suffix n, where dn is positive. Okay. When c greater than 1, c power 1 by n is some 1 plus dn, where dn is the positive real. Agreed? So from here what is c? Take on nth power, it is 1 plus dn, all power n. Agreed? 1 plus dn, all power. By Bernoulli inequality, this 1 plus dn all power n greater than or equals 1 plus n into dn for all n fallen n. This is why, because of Bernoulli inequality. By Bernoulli inequality, it is 1 plus dn all power n greater than or equals 1 plus n dn for all n fallen n. So that means c greater than or equals this one means c minus 1 greater than or equals n into dn for all n fallen n. Okay. C minus 1 greater than or equals n into dn means what is c minus 1 by n? It is greater than or equals dn for all n fallen n. So, but c power 1 by n, but from here c power 1 by n minus 1 equals dn. Okay, c power 1 by n minus 1 equals dn. So that means modulus of c power 1 by n, our requirement is, it is to show that limit c power 1 by n is 1. So consider modulus of c power 1 by n minus 1 equals mod d. What is dn? dn is a positive real, means it is dn. But what is dn? It is c power n minus, or yes, it is dn is positive. But this dn, according to this argument, from here what is dn? dn less than or equals c minus 1 by n. So it is less than or equals c minus 1 by n. Okay. Now, c minus 1 by n, that is c minus 1 into 1 by n. So listen, modulus of modulus of c power 1 by n minus 1 less than or equals c minus 1 into 1 by n. Here we know that c is positive, and that's a sequence of, sequence 1 by n be a sequence of positive reals, and when c greater than 1, c minus 1 always a positive quantity. When c greater than 1, c minus 1 is a positive quantity. So c minus 1 is positive, sequence 1 by n be a positive sequence of positive reals which converges to 0, means you can put a c equals c minus 1 and an equals sequence 1 by n. Then by our previous theorem, we have limit c power 1 by n equals 1. Clear? Okay. So when c equals 1, result is immediate, and c greater than 1, the result is proved with the help of that theorem. Now come to the next case. There are, if c result is proved for C equals 1 and greater than 1. So we check whether, what about when C less than 1? If C less than 1, since C is positive and C less than 1 means 0 less than C less than 1. Okay, 0 less than C less than 1. Since C less than 1, but C power 1 by n. Put a C power 1 by n equals 1 by 1 plus bn. 1 by 1 plus bn, where bn is positive. Okay, since C lies in between 0 and 1, or it is less than 1, so you can choose C power 1 by n as 1 by 1 plus bn, where bn is positive. So what is C? C equals 1 by 1 plus bn all power n. Again, so, but by Bernoullian inequality, 1 plus bn all power n greater than or equals 1 plus n into bn for all n fallen n. Why? This is because of Bernoullian inequality. Okay, so this means 1 by 1 plus bn all power n greater than, 1 by 1 plus bn all power n greater than or equals 1 plus n into bn. Therefore, 1 by, this means 1 by 1 plus bn all power n less than or equals 1 by 1 plus n into bn. So which is less than or equals 1 by 1 plus n into bn. Okay. So that means which is strictly less than 1 by n into 1 by bn. So that is C equals, or C, it is strict, that means we have C strictly less than 1 by n into 1 by bn. Here we cannot be use the previous theorem. Why? Because C less than 1, you can, what is 1 by bn? We cannot be say about this 1 by bn. What about its properties? So C less than 1 by n into 1 by bn. Again, so we have what, 0 less than C less than 1. That means it is 0 less than C less than 0 less than C less than 1 by n into bn. Okay, C less than 1 by n into bn, but C greater than 0. So 0 less than C less than 1 by n into bn. So you can multiply throughout by bn by C. You can multiply this result, this inequality by using this bn by C. What do you get? 0 less than bn by C into C, that is bn strictly less than, it is 1 by C, 1 by n into C. 0 less than bn less than 1 by nc. Now consider, since C is less than 1, consider 1 minus modulus of 1 minus C power 1 by n. 1 minus C power 1 by n, what is 1 minus, or simply 1 minus C power 1 by n. 1 minus C power 1 by n is, since C less than 1, C power 1 by n less than 1, so consider 1 minus C power 1 by n equals 1 minus, or it is less than 1 minus 1 by, what is C power 1 by n, equals 1 plus 31. So it is equals 1 plus 1 by 1 minus 1 plus 1 minus 1 by 1 plus bn. Okay, so that equals, it is bn by 1 plus bn. So 1 minus e power 1 by n equals bn by 1 plus b. Means, so listen, 1 minus c power 1 minus c to the power 1 by n equals bn by 1 plus bn. So it is strictly less than bn. Okay, bn by 1 plus bn is strictly, since bn is positive, bn by 1 plus bn is strictly less than bn. But what is bn? It is yes, bn strictly less than 1 by n into c, according to this inequality. So which is less than 1 by n into 1 by c. Okay, since c is positive, 1 by c is positive, and 1 by n be a sequence of positive reals with the limit 1 by n equals 0, then using that well-known theorem, limit c power 1 by n equals. Why? Because instead of c, here it is 1 by c, that's a positive quantity. Why? Because c is positive, and secants 1 by n be a sequence of positive reals having limit to 0. Therefore, according to that argument, that theorem, we have limit of c power 1 by n equals 1. That is, means it is obtained by using these arguments. We have said c less than 1 and c power 1 by n is chosen as 1 by 1 plus bn with the bn is positive. So this choice is possible. Why? Because c lies in between 0 and 1 or c less than 1. So from here you can take the nth power of c. C equals 1 plus 1 by 1 plus bn all power n. But by Bernoulli inequality, 1 plus bn all power n greater than or equals 1 plus n into bn. Therefore, 1 by 1 plus bn all power n less than or equals 1 by 1 plus n bn. This is strictly less than 1 by n into 1 by bn. Why? Because n is a n is a natural number. So 1 plus n into bn greater than this n into bn. So it is 1 by 1 plus n into bn strictly less than 1 by n into 1 by bn. Okay. So finally we have c less than, c is strictly less than 1 by n into bn. But c is a positive term. C greater than 0 means here combining you have 0 less than c less than 1 by n into bn. Okay, from here combining these two inequalities, 0 less than c and c less than 1 by n into bn, you can combine the right arrow as 0 less than c less than 1 by n into bn. So you can multiply this inequality throughout by bn by c. That's only for the sake of situation. So it is 0 again, c into bn by c cancelling each other, bn remains here, and it is 1 by n into c, bn cancelling, and 1 by n into c. Okay. Then, so consider this, our requirement is limit to c power 1 by n is 1. So c power 1 by n minus 1, either you can consider modulus of c power n minus 1, whatever may be, or 1 minus c power 1 by n equals 1 minus, what is c power 1 by n? This one. Equals bn by 1 plus bn. This bn by 1 plus bn, since bn is positive, 1 plus bn by 1 plus bn is always less than this bn. Okay. But what is bn? Bn less than 1 by n into c. So finally, you can take this one, that is modulus of 1 minus c power 1 by n is strictly less than 1 by n into 1 by c. Modulus of 1 minus c power 1 by n means modulus of c power 1 by n minus 1 strictly less than 1 by n into 1 by c. Okay. So this is in the form of our well-known proved theorem. Why? X equals xn be a sequence of reals. There exists a sequence n being a sequence of positive reals with a limit n equals 0 and a modulus of xn minus x less than or equals c into an, then limit xn equals x. That's our theorem. Here instead of an, here it is 1 by n, that's a sequence of positive reals having limit to 0, so that condition also satisfies. Since c is positive, 1 by c is also positive. Okay, so instead of c, here it is 1 by c, and instead of an, here it is 1 by n. So we can apply that theorem here. So finally it is limit c power 1 by n equals 1. Why? With the help of that theorem, yes, in the theorem it states that limit xn equals x. Instead of here xn, it is c power 1 by n, and x is 1. So limit c power 1 by n is 1. That's our requirement. Okay, thank you.